Good morning, students. This is Mrs. Sadi Joseph, your science teacher. Welcome back to the online teaching for the session 2020-21. Today, we are going to learn a new lesson, that is force and pressure. In this lesson, we will learn what is force and what are its effects. In the previous class, you have learned how objects move. Can you recall how we can decide whether an object is moving faster than the other? What does the distance moved by an object in unit time indicate? Yes, we can decide whether an object is moving faster than the other by its speed. What is speed? Speed is the distance moved by an object in unit time. Or we can write speed is equal to distance upon time taken. You also know that a moving object like a ball rolling on the ground slows down. Sometimes it may change its direction of motion. Why it happens so? It is due to friction. Now, tell me, what is friction? Friction is an opposing force which slows down the motion of an object. Let us recall some of our everyday experiences. I think all are familiar with the game football. What do you do to make a football move? To make a football move, you have to kick it. What do you do to make a moving ball move faster? Again, you have to kick it. How does a goalkeeper stop a ball? How do fielders stop a ball hit by a batsman? In all these situations, the ball is either made to move faster or slower, or its direction of motion is changed. To move an object faster or slower, or to change its direction of motion, you have to apply a force on it. Now tell me, what is a force? Force is a push or a pull. Actions like picking, opening, shutting, kicking, hitting, lifting, etc. are often used to describe certain tasks. Each of these actions usually results in some kind of change in the motion of an object. You can see one table here. This gives some examples of familiar situations involving motion of an object. If you want, you can add some more such situations or replace those given here, and try to identify the action involved in each case as a push and or a pull, and record your observations. Here we can see that each of the actions can be grouped as a pull or a push or both. In science, a push or a pull on an object is called a force. Thus, we can say that the motion imparted to objects was due to the action of a force. That means when you apply a force on the object, it starts to move. Our next topic is forces are due to an interaction. Suppose a man is standing behind a stationary car. See the figure. Will the car move due to his presence? No, not at all. It will not move. Suppose the man now begins to push the car. That is, he applies a force on it. The car may begin to move in the direction of the applied force. That means the man has to push the car to make it move. Some more examples are given. See figure number 11.3a, 11.3b and 11.3c. Can you decide who is pulling and who is pushing in these cases? In 11.3a, both the girls appear to push each other, while in figure number B, they are trying to pull each other. Similarly, in figure number C, the man and the cow appear to pull each other. From these examples, we can infer that these two objects must interact for a force to come into play. That means an interaction of one object with another object results in a force between the two objects. When two objects are in contact, then a force can apply between the two objects. We will see one activity. Choose a heavy object like a table or a box, which you can move only by pushing hard. Try to push it all by yourself. Can you move it? Sometimes. Now ask one of your friends to help you in pushing it in the same direction. Is it easier to move it now? Yes. Why it happens so? Can you explain? It is because when you push the box alone, the magnitude of force is less. So it is difficult to move the box. But when you and your friend both together apply a force on the box, the net force acting on the box will become more, and because of that, the box moves. Next, push the same object, but ask your friend to push it from the opposite side. Does the object move? This case also, sometimes the box can move. If it moves, then in which direction it will move? The box will move in the direction in which more force is acting. Here, the net force acting on the box will be the difference of both the forces. Another example, have you ever seen a game of tug of war? In this game, two teams pull at a rope in opposite directions. Members of both the teams try to pull the rope in their directions. Sometimes the rope simply does not move. Why? If the force acting on the rope from either side is equal, in that case the rope will not move. Suppose one team apply more force on the rope. In that case, the team that pulls harder, that is, applies a larger force, finally wins the game. What conclusion can you make from these examples? If forces applied on an object in the same direction, it add to one another. And if the two forces act in the opposite directions on an object, the net force acting on it is the difference between the two forces. We have seen in activity 11.2, when both of you were pushing the heavy box from the same direction, in that case, the box moves. But what happened when you and your friend push the box from either side? The box will move a little in the direction of larger force applying. Recall that in the tug of war, when two teams pull equally hard, the rope does not move in any direction. So we learned that a force could be larger or smaller than the other. The strength of a force is usually expressed by its magnitude. Magnitude means numerical value. We have also to specify the direction in which a force acts. So, to mention force or the strength of a force, we need magnitude as well as direction. If the direction or the magnitude of the applied forces changes, its effect also changes. This is the end of today's module. Go through the portion, read it nicely, and understand the main points. The rest of the chapter we will see in the next module. Till then, thank you and bye bye.